Okay, so section 1.3. Okay, let's try that again. 1.3, solving equations with variables on both sides. Basically, this just means exactly what that says. You are going to end up with variables on both sides. So, for example, if you have an equation like, let's go 12 minus 4t equals 2t plus 24. Okay, so basically what you can see is you have some t's over here and you have some t's over here, but the problem is they're on different sides of the equal sign. So anytime that you have variables on both sides, it's important that you can gather all of your variables on one side, and you could choose, and all of your constants on the other side. So I'm going to choose to put all my variables on the left-hand side, but it might change for every single problem. It doesn't really matter. You can move them to the right if you want to. So if I'm going to put all my variables over here, I have to figure out how to get this over to those t's. Well, anytime you move anything across the equal sign, you have to undo it. So this up here is a regular positive 2t, and in order to move it across, I'm going to minus 2t and minus 2t. So when I minus that, this cancels. So you can see they're all together on this side. And then I said that I wanted to get my constants on this side. So that means I'm going to need to move this 12 to the other side. So let's go ahead and simplify this a little bit further before we do that. So we're going to be left with 12, and then negative 4 minus 2 is negative 6t equals 24. And I've got to get this constant, because this 12 right here is a constant. I've got to move that to the other side. So again, I'm going to go minus 12 and minus 12. This is going to cancel. And then let me scoot over here because I'm out of space. Negative 6t equals, and 24 minus 12 is 12. Divide by negative 6 and divide by negative 6. So t equals negative 2. So please copy that problem into your notes, and just realize that it's all about gathering your variables on one side and your constants to the other. Okay, another example where we have variables on both sides. 2x minus 4 equals 4x plus, let's go 8. So, again, you're going to check your steps, and now I have some distributive property. So I've got to take care of it. So 2x minus 8 equals 4x plus 8. So I can see here that I have variables over here and variables over here. Before I start undoing anything else, we have to get those variables together. So let's put the variables on this side this time. So we'll move the variables over here, and we'll put the constants over here. And again, that's your choice. Okay, so if I want to move the variables to this side, I'm going to scoot this 2 over here. So this is a positive 2x, so I'm going to go minus 2x and minus 2x. So this is going to be gone. Negative 8 equals 2x plus 8. And then it looks like normal now, because now we have our variables all together. So minus 8, I'm out of space again, so negative 16, because this is negative 16, equals 2x. Divide by 2, divide by 2, x equals negative 8. Another example might be something like 15 minus 2x equals 3x. So this time, again, you still have variables on both sides. We've got a 2x, or a negative 2x, and a 3x, and we have to move those together. So this time there's no constant over here, like there's nothing to move it to. So I'm going to just go ahead and move the x's. I'm going to move the variables on this side, and I'm going to put the constants on this side. So I'm going to go, now I see a negative 2x, so in order to move it, I have to plus 2x, and plus 2x. Cancels that. You're left with 15 equals 5x. And now you're all the way down to a one-step problem. Divide by 5, x equals 3. So you're still getting to a solution. It just happens to be that variables are on different sides to start. So sometimes in algebra, when we have variables on both sides, sometimes we end up with something called a no solution. And it basically just means we go to solve it and you can't get an answer. There is no possible answer. So an example might be something like 2x plus 8 equals 2x minus 10. Okay, so again, we start the problem like normal because we're not necessarily going to know that it's a no solution. So again, I've got variables on both sides, so I need to get those together. So I'm going to go minus 2x and scoot it over here. Well, this one's gone, but then what happens is, so is this one. 2x minus 2x is gone because it's 0x. So this is gone and this is gone. The answer's not 8, the answer's not 10. We have to finish the problem. So we bring down what we still have left. On this side we have an 8, and on this side we have a negative 10. So you can stop here and realize that this is a false statement, because does 8 ever equal negative 10? No, it's never the same to have $8 versus being in the whole $10. That's totally different. So if you end up with a false statement, it means that there is no solution. There is no number that you could put in for x to make that sentence true. Okay, and then other times you end up with equations that have several solutions. So we call those infinitely many solutions. And basically what that means is you could put in any number that you can think of and it would make the sentence true. So for example, if we have 3x minus 9 equals 3 parentheses x minus 3. Okay, so again, you're not going to know that this is a special kind of problem. You're going to start like normal. So I see distributed property. Okay, so we distribute. Sorry about that. So we distribute and we get 3x minus 9, and then we bring down this other side. Okay, so again, we keep going. I've got variables on both sides, so I'm going to move them across. Minus 3x, I'm going to scoot it right over here, minus 3x. And what happens is these x's are gone and these x's are gone. You're left with negative 9 equals negative 9. So again, the answer is not negative 9. The answer is this a true statement or a false statement? This is true. Negative 9 always equals negative 9. So if you end up with something like this, it means that any number that you pick can go in for the equation and work. So you don't choose a random number and say, well, this one will work. You just write infinitely many solutions.